Okay, so for that rib, for creating that rib, to have a convenience, we are using this middle plane. Okay, otherwise we could have dragged it in one direction only, right? The total pad could have been taken in one direction, but just so we have that rib feature, okay, in the middle, we can use that same plane, right? Your middle plane, the one where we created the sketch. So that we can use if we use this pad on both sides. You observe.
I want it at both sides actually. So that I will get this center plane to create this stiffener. So I want to extrude it on both sides of the sketch. So for that I will use mirror extend, so that it will extrude on both sides of the sketch. Then I will give the total.
And when you are giving this mirror extend, make sure you are not giving the total distance 52. Don't give it 52 here, otherwise you will keep 52 on one side and 52 on the other side. In total it will be 104. Okay, what we want is total to be 52, so you give half of that. Okay, he is only calculating between the middle plane and the extreme. Okay, either of the extreme, left or right, doesn't matter. So you take the half of it when you're using mirror extend. Okay, that is another point to be remembered.
Width is 50. Total, not total, actually half of the total. So it will be 26. So you have to give half length. So here it will become 52 then. Then click on OK. So this portion is ready. So you can view it by making it shading with edges on. So in this way this portion is ready. Then the stiffener. So stiffener will be on the center plane, this vertical plane. So we will take that vertical plane and click on sketch. Then create one line. Then select this point. Control select this point. Then constraint defined in dialog box. Coincidence. Okay. Again select this point. Control select this point. Again constraint defined in dialog box. Coincidence. Okay. Then exit workbench.
Hey, hey,
Then click on this arrow below the solid combine. Click on that, and from here click on stiffener. Then give the thickness. So what is the thickness is 8. So give it 8, and we need it exactly around the center. So neutral fiber is already thick, so it is already coming the way we want it. So click on OK. So it is created. Now same thickness stiffener we will need on other side also. So for that select this stiffener, then click on mirror. Okay, it has selected actually the complete object. Okay, stiffener and face 1. Okay, we don't want to mirror face 1, we want the complete stiffener to be mirrored. So what we will do, we will go here, click plus before the part body, then click on the stiffener actually here, stiffener feature, then click on mirror, then mirroring element, define the mirror plane. So mirror plane will be at the vertical at the center, at the middle of both the object. So we will take this mirror and click OK. So in this way this object is ready.
Clear, right? We took that plane, middle plane, starting from the stiffener. Okay, took that middle plane, right? Clicked on stiffener, specified the distance, right? And then we mirrored it. Okay, just have a look at that stiffener command again.
Is already tick. So it is and from here isometric.
Okay, we took that middle plane and created that line, right? So that will serve as, so it will take up until it matches with that body, right? The body of that part. Okay, this line will go until that part. Okay, and then you can specify the thickness.
View. Then click on this arrow below the solid combine, click on that, and from here click on stiffener. Then give the thickness. So what is the thickness is 8. So give it 8, and we need it exactly around the center. So neutral fiber is already thick, so it is already coming the way we want it. So click on OK. So it is created. Now same thickness stiffener we will need on other side also. So for that, select this stiffener, then click on mirror. Okay, it has selected actually the complete object. Okay, stiff.
Yes, that this was also another good feature, that if you want to select a feature and it is not selecting, and it is selecting some other features, then you can choose the take the help of the design tree, okay, to select that particular element.
Stiffener and face one. Okay, we don't want to mirror face one, we want the complete stiffener to be mirror. So what we will do, we will go here, click plus before the part body, then click on the stiffener actually here, stiffener feature, then click on mirror, then mirroring element, define the mirror plane. So mirror plane will be at the vertical at the center, at the middle of both the object. So we will take this mirror and click OK. So in this way this object is ready. So after that,
No doubts, right, in this one?
we will create this next object. So again click on start, mechanical design, part design. OK. Now for this object, at first we will create this bottom plate. So we will take horizontal plane for that. So click on sketch, click on horizontal plane, then create these two circles at the gap of 100. So take the circle command, create the first circle here, then second circle here, and give the gap between two circles. At first give the circle radius. So first circle radius is 21. Again constraint, give the other circle radius. So other circle radius is 65 is the diameter. So double click, make it diameter 65. Give the 65. Then the gap between two circle is 100. So click on this vertical and this center point and make it 100. Then these two lines are tangent. So create tangent line from here. Click on the arrow below the line and take bitangent line. Click on the first circle, click on the second circle. Again bitangent line, first circle, second circle. Click on both the circle. So this is ready. Then we don't want internal circles, so just double click on the quick trim and remove them. Okay. So you have to create a single shape, outside boundary of the shape. Then click on exit workbench. Then make the pad of it. So it is a pad of 12 size. So click on pad. So before that, actually suppose if we want like this, so we have to interchange the radius actually. So we just double click this and we will make it 65 diameter, 65 diameter, 65, and here we will make it diameter 42, 42. Okay, exit workbench. So it has been created like this. Then make the pad, the thickness is, pad thickness is 12, give that 12 here, enter. So this bottom pad is ready. Then create this circle again here, sketch, select the surface and circle, and select this circle and this circle using control, then constraint dependent dialog box and make it coincidence. So it will automatically take that diameter or radius. Same way,
I'm sorry, I was on mute. So if you don't know the exact dimension and you again have to check the drawing, right? Otherwise, what you can do is you can just draw a random circle and click on that circle, the last one, and click on coincident, right? That's what he did.
then constraint dependent dialog box and make it, and select this circle and this circle using control, then constraint dependent dialog box and make it coincidence. So it will automatically take that diameter or radius. Same way here also, we'll take one circle, then control select this outside arc, then constraint dependent dialog box coincidence. Okay, so they are properly placed. Exit workbench. Now we have to make pad of this circle by the height of 36 minus 12, that is 24. So we'll make pad. Now we want only at the at this time actually these both circles are in the same sketch, but we want to make the pad of this circle only. So therefore in on this no selection, right click on no selection and click on go to profile definition, then select this circle. Okay, and give the thickness of 24. Okay, so it will create pad of that circle only. Same way for this circle, pad, right click on this selection, no selection, profile definition, select this circle. Okay, give the thickness of 12. Okay, so total height will become 24 here, here 36. Then next are the these two holes, through holes. So again sketch, select this surface, circle, then select this circle and this outside circle. Constraint dependent dialog box, make them concentricity. Click on concentricity. So those will be automatically concentric. Then using constraint, give the parameter of internal circle. So it is 24 diameter. Then exit workbench. Then make the pocket. So I want through pocket. So click on this dimension and click to up to last. Okay. So this through pocket is created. We'll just make the edges on, shading with edges, so it will be visible properly. Then next is this circle, this surface, again circle from the center point, constraint, give the diameter. So diameter is 36. Give 36. Exit workbench. Then click on pocket. Up to last is already selected. Okay. So this is also created. So we can make this. Okay, exit. Then we can make this line. Okay, it is going in the editing. We can make those lines. So this is the sketch. So right click and hide it, so it will be invisible. Then next is the internal. Then next is internal circle, internal. stiffener we have to create it. So before that we can create this keyway 12 by 5. So again sketch, select this surface, then I want it internally, so I will create suppose one rectangle. Then I want this rectangle symmetric, so I will create one axis and select this line, control this line and axis, and click on constraint define in dialog box symmetry. Okay. Then next I want it to be tangent to this circle. So select this circle and this line and constraint define in dialog box tangency. Okay. Now I want this height to be 5, and if we define it from center, that means this 5 and this 18, that is 23. So we will give it from center constraint. From this it will become 23. Okay. So actually we will not.
Was that clear? Using those dimensions, instead of specifying from here phi, he specified it from the center. Okay, you see,
And this 18, that is 23. So
this 18 is from this what do you call, middle to up to here, right? The radius of that circle is 18, and if you add plus phi, okay, which is this, it becomes 23, right? So instead of specifying phi from here, he specified it from there. So 18 plus 5, 23, up until here. Okay.
we will give it from center constraint. From this it will become 23. Okay. So actually we will not need this tangency. We will need it to be inside. So it will cut properly. Then we will give the width of 12. So constraint, click on this line and make it 12. Okay. So it is properly defined now. Exit workbench. Then pocket, click on pocket. Up to last is there. Okay. So in this way this keyway is created. Click on zoom fit. Then last item is this stiffener. So that stiffener will come on the this vertical plane. So select that plane, sketch, then create one line here, line, then select the corner, then select this line by pressing Ctrl, then constraint define in dialog box coincidence. Okay. Again this line and this line, constraint in defined this point and line actually and coincidence. Okay. Then give the constraint from this point to this axis. So it is for the bigger circle, that is half of the 65. So just double click, give 65 divided by 2, enter. So it is 32. Same way for this constraint, from select this point, this axis, and give the radius of this circle, it is 21. So double click 21. Then at the corner you have to draw a small line, otherwise it will not create the stiffener. So create one small line here and other small horizontal line you have to create it, so it will merge properly. Exit workbench, then isometric zoom fit, then stiffener. Click on this arrow below this solid combine, stiffener, give the thickness of 12. So in this way zoom fit, So in this way this object is ready. So in this way both the objects are created. Okay, so we will stop here. You can view the next video here, and if you want to view next exercises, visit this video. And if you want,
Okay, so that's what is about that part modeling. Okay, so mostly instead of using dimensions, we can use relationships also, right? Constraints are very useful in defining the relationships, right? So instead of specifying this dimensions, you can just specify that these two are what do you call, coincident, concentric, right, parallel, etc. And as and when required, you can give the dimensions also. Okay, no doubts in these exercises. So we saw this today, right? This one, right? After drawing that two bigger circles using we drew a random line, and then uh, took it took use of the actually that bitangent line, right? When we click on this circle and that circle, it will create a line that is tangent to both the circles. So similarly for this, and by the way, you can even do only half of this, right? Because it's symmetric, right, about this axis. So you can draw only half of it. Like for example, you can just draw the upper part, right, or the lower one, whichever is your choice. So, and then we can mirror this, isn't it? But generally using these circles and all of this, it will be good. Okay, so that's why we prefer for drawings like this, we'll just draw a complete view. But for those which are having more features, then we'll go for only half symmetric view, that will only model the half part and then mirror it, okay, in the sketch itself, and then we can extrude that or pad it basically in CATIA. So that was there, and we had drawn this inner circles, right? We used concentric features, right, to define, because we don't know if they are at the exact center. They are actually concentric as per this drawing, but when we draw there, we just draw some random circle. This circle we will draw randomly, and then we will select this circle, right? This circle we will select, this circle we will select, this arc basically, and then we will go to constraint defining dialog box and then select concentric, so that we can tell the software that these circles are having the same center. This center, right, is same for both. So similarly here also same thing, right? After that we can just use pad. How much is the pad distance? Is it given here? I think here it will be given. It is not given, I guess. So we can take any random dimension, right? Like maybe 20 or 30. So that's what is about the exercise 5. Okay. Other than that, you have this one, right? Quite simple, isn't it? We have to create these two axes, right? Because we have covered the commands, right? And those three exercises, which are somewhat difficult even this one. So this is why when you look at that and come back to this will become very easy, right? So after drawing those two axes, you can draw a rectangle basically, because we can trim this one later, right? This line. So different ways to do it. For example, here they are showing, okay, they are showing it like you can draw the outer loop first, okay, randomly, and then give the dimensions, okay, and in the end you can just draw that middle circle, right? After that you can use pad to extrude it so that we can have it like this, right? So that is about that. And about this we saw a very similar one, just that we did not have this one middle one, okay. So simple rectangle first, and then this one middle one, right? How you can draw this? You can use that I believe the slot feature is there in CATIA. If it is not there, then what you can do is you can draw a rectangle first, right? Isn't it? And then you can draw this circles, half circles, or maybe full circles, and then you can trim this part, right? Like that, and trim this middle one also, so that we can have this whole feature. And what you can do is take this, what do you call, these two circles, and this another axis that you can take, okay, define an axis. You take these two circles, this axis at the end, and then you make them symmetric, okay, so that it is in the middle. Fine. And about this one also, you can take this axis, okay. Even if not the axis, you can take this axis, right? Standard axis, it is already there, no need to draw this again. So you can take this axis, firstly select these two lines and then this axis, and then you can make them symmetric. Go to constraint defining dialog box and make them symmetric. So that's how you can do that. And after that, you can draw the circles, right? Basically you can draw one circle, mirror it here, isn't it? You can draw this circle, this one, okay. You can define the dimensions, okay, like this center, either from this edge, okay, how much is the distance of that center, or you can even specify it from the middle, from this center, right? Whichever is available from the drawing we can use. So it's actually from the corners which is available, right? Even this one is also available, like from the center of the circle is 40, right? From this part center, the center of the circle is 40, 80 by 2, right? So that, or even you can specify from the edge 20 horizontally and 20 vertically, so you can have this position of the circle. So once that is done, you can mirror it, right, using this vertical axis here. And then when these two entities are available, you can take this axis and mirror these two there, and then you can extrude it. That's all, right? And now assembly is remaining. So for that assembly, we'll hopefully see in the next lab. Okay, so that's a stuffing box. So you have different parts, and then we'll join using those constraints we saw, right? Contact constraints, coincidence constraint, right? You have different parts, bush, and these glands, studs, hexagonal nut, and then this color graphics capability to indicate the different parts, right? Doubts in today's exercises? You have to remember the constraints. Okay, how you can better utilize the constraints, okay, to save time, right? And you have to remember what those constraints mean. Okay, otherwise it will be like the intention from the designer side will not be, what do you call, communicated to the software, isn't it? So you have to understand what the constraints mean, and you have to check whether the drawing is fully constrained or not, because if it is not fully constrained, then it can move in space, and any other change you made later, okay, will affect your previous changes. So we are trying to constrain it fully because we don't want to change as and when we are moving forward. So if there are no doubts, then we'll end the class. Okay then, thank you.